we're saying now. So it's my great pleasure to host the second masterclass that we organized in the context of the virtual Spring School in Advanced Methods at the University of Oxford, Department of Politics and IR. I can see that many people have been joining, and we're expecting even more people as we get started. So today we are going to be talking about, I think, a very important issue in political methodology, not only political methodology, social science methodology in general. I remember when I was a graduate student decades ago, not decades, but ages ago, I remember seeing a paper in political analysis by Gelman and, was it Boris Shore? I don't remember. I don't remember the actual name of the other author, and I was like, that's a hard paper to read. I don't really get what's going on, and I don't get the point of it. And then a couple of years later, little did I know, a lot of papers were citing that paper, and there was a whole thing about MRP and post-stratification and words that I never envisioned that I would be saying when I started learning about politics, when I started studying political science. So today we're going to be talking about multi-level regression with post-stratification. And I have the pleasure to introduce our speaker, who is an expert on this methodology and other methodologies, if I may say, a great political scientist from the University of London Royal Holloway, Chris Hanretty, who is going to be giving a talk today about like a primer on MRP. And as always, because this is a masterclass, we're also going to be having a bit of code for you. The code is going to be available on GitHub. It's already there. You can go and check it out. If you just Google Chris's name and GitHub, you're going to see that there is an Oxford MRP repository that you can check out and see how it looks. And there's also, there's also a great paper in Political Studies Review, I think from 2018, if I don't remember the date.
It came out online in 2019.
2019, yeah, which has everything there, and I strongly recommend this paper. Even I managed to run an MRP using the code by Chris. So without any further ado, Chris is going to start talking. 45 minutes for the talk. Q&A. There is a Q&A button here. I strongly encourage you to ask questions. When we move to the Q&A at around 6, I'm going to be asking the questions to Chris. You're going to be getting the answer. And then we're going to move to the coding part of the talk. If we need more time for the Q&A or more time for the code, we have flexibility. Everything's going to be fine. So, Chris, thanks very much for coming. The floor is yours.
Thank you. Thank you very much for the invite. And thanks to you and to Dorian for organizing this session. I'm going to share my screen now, and everything is going to be run from my browser. You should be able now to see my screen, and you should notice the address bar in my browser gives the location of the slides, and this highlighted link here gives the address of the GitHub repository, which contains 2 short code snippets. So hopefully, as you've just heard, the outline of that talk is fairly clear. I'm going to be giving you an introduction. I'm not going to be assuming anything about your knowledge of MRP. We're going to be starting from 0 knowledge and working up. And in particular, in the first half, the overview section, I'm not going to mention any stats software at all. After we have the Q&A and we move beyond that into the code snippets, I'll be showing code snippets for R because R is all I do these days. And do feel free to bow out at any time. If you've got what you want from the session and want to stop there, that's fine. I won't be offended. So if you want to capture those addresses, do please take a screen grab now before I maximize the screen and you can see everything just a little bit better. Okay. So in order to motivate the use of MRP, I want to give you a couple of use cases or example scenarios. Let's say that you are tasked with improving opinion amongst elites of UK universities. You want to show MPs that everyone in their area really loves universities, even if they're an MP from a rural area. So you want opinion at the level of the constituency. Or if you're not working in public affairs, you're working in some kind of real-time analysis, you might be doing some on-the-night analysis for your national broadcaster. And you're trying to track the results as they come in, maybe for some crazy new referendum on an issue that no one's ever really thought about before. And you want some kind of ex-ante estimates of how each area will vote before you get the results in, so you can update on the fly. Here again, area opinion estimates would be good. So these are two use cases which are examples outside of the academy, but you might have in this context a very obvious interest in testing some relationships. You might be interested, as I am, in representation. How do members of parliament represent opinion in their area? So you're interested just in a straightforward association, a correlation. But in order to get that simple correlation, you need to do a whole load of work to estimate opinion in a small area. Of course, you might not be primarily interested in the relationship between district opinion and some legislative outcome. District opinion might be for you just some kind of other control variable that you want to throw into your model. Maybe you believe that there's some effect of district magnitude on legislators' preferences for trade liberalisation. And there are good reasons for thinking that, but if you're doing that, you might want to control for preferences in each district, because we know that districts with smaller magnitudes tend to be more rural, and more rural areas have distinctive preferences. So in each of these cases, there might be a use which MRP responds to. And the general problem to which MRP is an answer is sometimes in geography referred to as a problem of small area estimation. We have information on some kind of population, typically, although not always, a nation state. And we want to estimate quantities about subpopulations, typically, although not always, smaller geographic units. Other kinds of subpopulations might be subpopulations by other stratifying variables, breakdowns by class, gender, or ethnicity. So this is the general problem. It's a particular way of viewing the problem. You don't need to think about it in terms of population and subpopulation. You can just treat each unit, each small area, as a population in its own right. And if you're in that first use case that I discussed, if you're trying to use estimates of local opinion for lobbying, well, you could just treat each constituency as a separate population and poll in that population. But that's going to be pretty expensive and definitely not possible if you want to replicate that across several hundred constituencies. So if that's the general problem that we face, one of estimating opinion in subpopulations, what would be the kind of that naive approach? Where might we improve from there? Well, one way would just be to take our survey, whatever information gives us measures of opinion on the population, and split that up. Take subsamples for each distinct subpopulation. So here's an example of how that strategy might work. Let's say that you were trying to work out how different local authority areas were going to vote before the EU referendum. Let's say that you had a tracker poll which had been running for the past 3 years. One poll, 1,000 respondents each month for 36 months. You could combine all of those, have a total sample size of 36,000. You then divide those up into lots of different sub-samples. If you were looking at the UK, you'd end up with a sample size of around 95 respondents per local authority area. And with the sample size of around 95 respondents per local authority area, you get an estimate, certainly, of opinion, but that estimate would be very imprecise. You'd have a margin of error under some assumptions of plus or minus 10%. And that wouldn't be, I think, a very good description, although it might still be useful as a guide to interpretation or a control for predicting. So if that itself isn't very good, how can we improve on that? Well, the very basic outline of the MRP approach is to take our national sample, our national survey, try and model the outcome of interest using, and here's where the multi-level term comes in, some kind of small area random intercept plus information on the respondent type or respondent strata. For example, a respondent type might be males between the ages of 25 and 34 who left high school without qualifications and who are currently employed. That might be a particular respondent type. And we would use that kind of information to help us build a model. We throw in lots of random effects for age groups, for gender, for employment type, for highest level of qualifications, and so on. So in that first step, we'd estimate a model. That model would rely on the information from a national sample. In a second stage, we'd bring in a new source of information. We'd bring in a post-stratification frame, something that tells us, for all the types of individuals encompassed in our model, exactly how many individuals of that type live in each area. And so a post-stratification frame might tell us that in Aldershot, there are 530 men between 25 and 34 who are currently working and who left high school without any qualifications. Once we have those two sources of information, which work with the same types of respondents, then after that modeling exercise, it's all just about adding up. So MRP, although it sounds complicated, is ultimately quite simple. The most common operation is addition, because you just create predicted probabilities of holding a particular type of opinion. And then we add all the predictions from our model and weight them using the counts from our post-stratification frame. So the basic logic is simple, even though the implementation, which I'll go on to discuss, can be quite complicated. And this is a strategy which can be used for any kind of opinion. It could be some kind of continuous measure like a feeling thermometer. It could be a dichotomous variable, whether you support or oppose higher taxes, or it could be a multinomial outcome, as in the case of vote intention. I like MRP. I use it a lot. There are some circumstances where you probably wouldn't want to use it. It's most common to see MRP used to generate an independent variable. It's quite rare to see MRP used to generate the outcome variable. That's not because we're uninterested in place level outcomes. It's just that we're more often more interested in individual level opinions for individuals who happen to live in particular areas. So for example, you could use MRP to estimate, let's say, how supportive of same-sex marriage are areas where there's been a gay pride parade recently. Or you could use MRP to estimate how pro-redistribution areas are which used to have a coal mine. Those are interesting questions. Do particular types of places, particular types of local histories cause people's opinions to be different? But in that case, you probably just go straight to the individual level of analysis and model the opinions of people living in those types of areas. So MRP is not something that you use in all contexts without thinking. You probably got the intuition by now, but if we want to boil it down to the simplest possible example, we might have just the most simple possible example. We've got a population which has multiple different areas and where each voter is of one of two types. Either they're red or they're blue. And in this toy nation, we have a census which tells us exactly how many reds and blues live in each area. We collect a national sample asking individual reds and blues whether they think Twitter is good or bad. We run some kind of logistic regression using color, in this case, as a predictor. And then once we've got that, all we're interested in are the probabilities of thinking Twitter is good, given that the respondent is blue or red. And we just end up multiplying the number of individuals who are blue in any given area times their probability of thinking that Twitter is good. You can get more complicated. You could say at this point, well, ultimately, if you've got 530 individuals who are red in a particular area, then the number who believe that Twitter is good is unlikely to be exactly that probability times the number. You got to have integers here rather than real numbers, but those are additional complications. So the basic idea is very simple. Estimate a model on national data, combine that with information about the distribution of types of voters or respondents in each area, and add up. So far, so simple. But what do you need in order to carry out this kind of analysis? Well, what I'm going to do is take you through the two key inputs, which are the survey and the post-stratification frame. You're almost always going to be working with survey data for MRP. And I'm going to list a series of fairly obvious requirements. Your survey must include information on some kind of outcome. And although this requirement isn't strictly necessary, your survey really should include information on which small area the respondent is in. If you have a survey which hasn't collected that kind of information, it would be very difficult to use it for MRP. You could just exploit the demographic characteristics of the respondent, but it would preclude you from using lots of other information, not just the bare fact that they live in a particular area, but also lots of area level predictors that you could merge with your survey data. Your survey data should include all of the individual level predictors that you want to use, all of the information that builds up respondent type. So that might be information on gender, age, highest qualifications, employment status, and so on. If you're commissioning a survey, then you get the chance to make those explicit. If you're not commissioning the survey, if you're working from a national election study, you'll have to deal with what is there. You don't need respondents from all the areas that you're going to make predictions for. So one problem in lots of MRP applications is it's really hard to get respondents from small outlying areas. In the US, really hard to get respondents from Alaska. In the UK, very hard to get respondents from Shetland Islands or the Outer Hebrides. You don't have to have people from those areas in your MRP survey, but it will help if you do. I think it would definitely be a problem if you're missing information for a lot of areas. So, for example, the British election study prior to 2005, the face-to-face surveys stopped interviewing people north of the Caledonian Canal, that stretch of water that kind of bisects the area of Scotland. That's a big problem because it means that there's some areas that your survey is just not going to touch and areas which might be distinct in their own way. So that's what you need for your survey. You are hopefully going to have a large survey. There's no minimum. And I don't even think there are any strong rules of thumb about the minimum sample size that you need, because that sample size is going to depend on the number of small areas, the power of your individual level predictors, and also the class imbalance, particularly for categorical outcomes. So let me give you, some examples of that. Let's talk about the number of small areas first. If you're doing MRP in the US and you're interested in state level estimates, that's a lot easier than constituency level estimates in the UK, just because you've only got 50 areas rather than 632 for mainland Great Britain or 650 for the UK as a whole. Situation is slightly easier if you're in Switzerland, if you're Canton still. You might also be making life difficult for yourself if you're modeling rare outcomes. And so in the UK recently, we've had certain scandals about behavior in public office. And so we might commission a survey, how many people are aware of the tremendously important body that is the Advisory Committee on Business Appointments. That is a rare outcome. The number of people who are aware of that body is low. And if you have a very rare outcome like that, or very imbalanced classes, it's going to be hard for you to extract patterns which allow you reliably to link predictors to knowledge of that committee. In the case of vote share, I always struggle with modelling vote intention for Plaid Cymru, the party that only stands in Wales, just because I'm necessarily limited to Welsh respondents, and even amongst Welsh respondents, support for Plaid Cymru is not very large. The final point is that MRP is more feasible the more powerful your predictors, right? So if I'm modeling something like vote intention, that's great. Because if I'm modeling vote intention, I have a really, really powerful area level predictor, which is what happened in the last election. That is tremendously predictive, and that's the basis of simple methods for election forecasting like uniform national swing. If I'm working for a commercial provider and they're saying, well, why don't you do MRP for how popular Deliveroo is or Uber Eats? Much harder to predict that. Can I include as an area level predictor the number of takeaway restaurants in an area? How predictive is that going to be? Do I have to include things like internet access? I definitely don't have past information on something like this. So all of these factors are going to change what is feasible for you. Here, however, I am able to benefit from some systematic review carried out by one of my PhD students, Ben Lobo. And he's found, after combing through lots of different MRP publications, that the median sample size tends to be 7,000 to 8,000. There's a very, very big interquartile range. And so for some of the stuff on US states, you regularly get sample sizes, national sample sizes of 1,000 to 2,000. And thinking about that US example, another metric is not to look at the total sample size, but rather the number of respondents per area. And so if you are working in the US or Switzerland or another area with relatively few small areas, then you probably want 80 to 100 respondents per area. But if you're in the UK, then 20 respondents per area might be reasonable. That's the kind of logic which suggests that for the UK, you'd want a sample size of around 12,000. I would never say that doing MRP with fewer observations in that is wrong. It's just something that you have to be aware of, and generally the bigger the better. But of course, you also have to think about sample quality. So MRP, because of the post-stratification step, doesn't necessarily need a representative sample. If you know that your sample is unrepresentative because particular types of voters had a higher probability of selection into your sample, well then you've got the post-stratification frame to tell you exactly how many people of that type there should be. So you're estimating your model and you're relying on the post-stratification to turn that information back into something that matches the population. So it's analogous to weighting. And where you have a non-representative sample and where the non-representative character of that sample is included in your model, you can get decent results. There's an infamous paper which used results from repeated surveys of Xbox users to generate predictions of the 2012 US presidential election. Infamous because the population of Xbox users is in no way representative of the general US population, much more male, much younger. But the authors argue that by using that post-stratification, they were able to remedy some of that initial imbalance. What this means is that if you are doing MRP and you've got some data which has come to you from a survey provider, from a polling company, and they regularly weight on certain variables, then they're worried about non-representativeness on these characteristics. And so they should be in your model and in your post-stratification frame. If you are working with data that you've commissioned yourself, you will be able to avoid one of the most frustrating problems in MRP, which is when the variables aren't recorded in the way that you need them to be. So on at least one occasion, I've ended up in a situation where my survey didn't have year of age, but had age groups, right? So I had something like this. I had an 18 to 19 group, a 20 to 29 group, a 30 to 39, and so on. But when I went to look at the census for that particular application, I didn't have an 18 to 19 group, I had an 18 to 24 group. So this is one of the things to be aware of. It's probably only relevant to you if you're commissioning something. Just you have to be very sure, you have to do the homework in advance, you have to construct your post-stratification frame or check it and make sure that the response options in your survey match what you're going to be post-stratifying to. So do try and base any question wording as closely as you can on the census or whatever other instrument you used to build your post-stratification frame. So that's the other side of things, the post-stratification frame. How do you get one of those? Well, post-stratification frames represent a really big startup cost for anyone interested in MRP. And I think I say it later on in the slides, but if you're asking, where can I get a post-stratification frame? The best answer is from someone else who has already done the work, right? Because it's one of these things which is part art, part science, and involves lots of compromises. And if you've had someone else, particularly someone who's got a published article using a particular post-stratification frame, much better to use that than try and reinvent the wheel. But I am going to talk about this. I'm going to talk about post-stratification frames varying in complexity. So the number of variables that make up different voter types, and also in terms of their analytic or synthetic character. So how much the joint distribution of characteristics is itself a product of modeling decisions. I'm going to try and illustrate those two dimensions by taking you through a couple of specific examples. So I'm going to start with one of the most widely used post-stratification frames, which is the American Community Survey. It's not a census, but it is a large government survey which has sample sizes in states and even in congressional districts, which are large enough that researchers can use this as a basis for post-stratifying. Typically, when researchers are using the ACS for post-stratification, they combine multiple years to make sure that they've got enough observations. And if you're using it, you can either use the pre-calculated tables that exist. So there are pre-calculated tables for some three-way combinations, like age, sex, and race would be one. I think there might be some four-way pre-calculated tables, so age, sex, and race by education. But if you don't find the table that you need, the ACS rules are fairly permissive, and it's very easy to download the microdata and just use that as the basis for your post-stratification frame. So you download the microdata, you'd aggregate by unique combinations of the variables you're interested in, and just count up the observations for each voter type. So that's something which exists off the shelf and is one of the post-stratification frames with the lowest startup cost. Lots of papers have used ACS data in the past. It's fairly easy to find code for that. An example might be a recent methods paper by Gao, Kennedy, Simpson and colleagues. It's a methods paper, so they go overboard a little bit, but they download the 5-year aggregate of the American Community Survey, and they end up with a post-stratification frame with 2.5 million types. So all the combinations of state, sex, race/ethnicity, education level, income, and then age. They include single years of age just because they're doing something slightly funky with the age predictors. Don't do that. That collapse your age categories. But it's not an unreasonable level of complexity in terms of the number of voter types, right? So often when you're dealing with post-stratification frames, you'll have a data frame with 1-2 million rows. That's the US. If we come back this side of the Atlantic, we could think about the 2011 census. So the rules in the UK on microdata are a bit more restrictive. And so certainly when you're thinking about constituencies rather than regions, you can't ever get microdata, which tells you which constituency each census respondent is from. So in past work, what I've done is I've used national census microdata and marginal distributions for each area, and I've combined those by raking. So when I talk about the marginal distributions, I'm just talking about the proportion of people in each area, in each constituency, who are 18 to 24, the proportion who are 25 to 34, and so on. When I'm talking about the joint distributions, I'm talking about the proportion that are 18 to 24 and male and have a specified level of education, and so on. So the census microdata can tell me that joint distribution. I've got that raw data, and that characterizes the joint distribution. But that joint distribution might not match the targets that I have for each specific area. So I repeatedly rake it, as to say, multiply the kind of number of observations of particular types in order that when added up, these weights add up to the marginal distributions I want to match. And in the code snippets, I show a worked example of how that's done. A couple of other examples of post-stratification frames quickly, which are becoming less analytic and more synthetic. There's more modeling going on here. So a recent commercially successful example is the YouGov post-stratification frame, which is extensively documented in a wonderful paper by a couple of people I've occasionally co-authored with. What they do is they start with the annual population survey, which plays kind of the role of the American Community Survey for the UK. But here, because they're typically using it to generate election forecasts, and because how you voted in the past is a really good predictor of how you will vote tomorrow, they augment that post-stratification frame. They get all that microdata and they impute how people might have voted. So they have past information, which contains respondent characteristics and vote choice. They estimate a model on that, and they use that model to impute multiple copies of vote intention for the individuals in that microdata. Once they've got that joint distribution, they can again rake to these known totals. So that even if in any particular area, you had relatively few Conservative or relatively few Labour voters, those numbers get squished down or multiplied in order to match. And so their data frame, in theory, has 3.8 million voter types, but not all of those voter types are realized. So there's some odd combinations. There might end up being no people who are 18 to 19 who have postgraduate level qualifications, for example, for obvious reasons. If that has started to make you think, oh, there's a lot of modeling going on behind the scenes, maybe that's making me feel a little bit queasy, it gets even more extreme in this direction. So some authors have said, actually, a lot of the time, you don't even need information on the joint distribution. You can just take the marginals and multiply them. So that's the kind of thing which makes your head explode on the first time of listening, at least if you're used to thinking in terms of marginal and joint distributions. So you're telling me that if I don't know the number of people between 65 and 74 who have a university degree, I can just take the proportion that are 65 to 74 and multiply it by the proportion that have a university degree. And that works. It seems like it should be wrong, right? We know that the proportion of 65 to 74-year-olds who have a university degree is much lower than the general population because we've expanded higher education massively. And yet what this paper does is show that a large part of these errors end up cancelling out. So if you only have information on marginal distributions, you can still get a fairly good approximation as long as you're not exposing any of the subpopulations. It would clearly be wrong to use this to try and model opinion separately amongst older voters in each area. But there are possibilities. And so generally, post-stratification frames are going to differ in terms of not complexity, number of rows in the frame, but also in terms of the volume of modeling that's gone into generating that post-stratification frame. My impression is that all applications of MRP for vote intention polls and most applications of MRP for social science questions involve some degree of imputation of past votes, right? That's necessary. There's never going to be a census which asks people how they voted in a past election, but past vote is a really powerful predictor for most of our purposes. And so imputing it is really helpful. There are some kind of complications here. There are always issues about the freshness of these post-stratification frames. In the UK at the moment, we're partway through completing the census, or rather the census in England and Wales, Northern Ireland and Scotland. And so any post-stratification frame done on the last census in 2011 is going to be a little bit stale. You can get around that by using some of these census-like things like the American Community Survey or the Labor Force Survey. But here, there's a different kind of problem. You're building one kind of survey technique upon a survey. Right? It surveys all the way down. So given all these complications, if you can, the best thing to do really is get someone else's post-stratification frame, load it into R, see what it looks like, and play around from there. If you're not in that happy position, or if you know that you can't get anything like a census, there are ways around it. So you might not have anything that would help you build a post-stratification frame because you're working at really low level. Because in order to get the census outputs you need to go and sit in a hermetically sealed environment in some government office somewhere, or there's no census to speak of. Either it's very old or it's just impossible to collect at the moment. So in that kind of situation, you do have some options if you're interested in an opinion in different areas. You can just bet the bank on your area level covariates. Right? So that's a bit like saying there's just one type of voter in each area, and we're going to model how their probability of having a particular opinion changes, not as a result of changes in their voter type, but as of changes in the area level predictors that we include in our model. And that, that can work. Area level covariates are really important, but it's not going to help you if you have some of the problems of unrepresentativeness of your underlying sample. So those are the two inputs that you need for any application of MRP. You then need to make a series of modeling choices. So this is the last chunk of things that we need to think about. You need to think about the type of model you're going to use, the individual level predictors, and the area level predictors you're going to use. And I'm going to go in reverse order. Start with these area level predictors. These often are going to be the biggest contributor to the predictive accuracy of your model. And there are a couple of papers that suggest as much. So just having the right set of area level predictors can do as much for you in terms of predictive accuracy as having the actual post-stratification. So where do you get these predictors from? They might be lagged versions of the thing you're trying to model. They might be obvious correlates. So if you're asking some question about ideology, then the Labour or Conservative vote shares or Democrat or Republican vote shares might be obvious correlates. They might be necessary conditions for a particular type of opinion. If you want to model the proportion of people who have an opinion on pret-a-manger or insert high street store of your choice, you might want to include the number of such stores in that area. But you probably want to be looking to theory and past practice. There's no canonical set of predictors that we use in MRP. I certainly can point you to past area level predictors that my PhD student Ben Lobo has identified in his systematic review. So characteristics like the average age in an area, party vote shares, levels of income, unemployment in the area. These are all area level properties which people have found useful in the past and which you might therefore find useful too. So that's one type of variable selection. Another type of variable selection is selecting the individual variables you want to use. Much of the time, that won't be something you have much choice over. You may be limited to individual level variables which feature in your post-stratification frame. You can, of course, include interactions between those variables. So one interaction I've found to be particularly helpful is the age education interaction, because the meaning of having a degree, if you're 65 plus, when having a degree was fairly rare, is quite different to having a degree now when it's much more common. And you've also got the option of cross-level interactions. So one stylized fact found in analyses of US voting behavior is that rich people in poor areas vote differently to rich people in rich areas. So that'd be an example of a cross-level interaction where we've got individual and area level income interacted one with the other. So we have some ideas about the individual and area level predictors that will feature in our model. How do we choose what model to use? Well, most of the time, you'd be using a multi-level parametric model. If you've got a continuous outcome, you'd be using a multi-level linear model. If you've got a dichotomous outcome, a multi-level logistic regression. However, there are a number of recent methods papers which suggest maybe we should think about using non-parametric techniques or machine learning techniques. We could split the difference. We could use parametric techniques, in particular Bayesian parametric techniques, but we could place priors on our variables so that a lot of the variables end up being shrunk to zero. So we get what ends up with being a relatively sparse set of predictors. That's where the frontier is at. I'm not going to show you those. I'm just going to illustrate MRP using Bayesian methods in R, which I think is advanced enough for the time being. If you want to get more complicated, you're going to have to deal with issues about working out your pipeline. If you say that the best way of doing MRP is to have an ensemble of different models which are combined using Bayesian model averaging, then that's a lot of moving parts to get right. If you then want to say, well, of those different models I tried, I love these neural networks, or I love these regression trees. They're also difficult to interpret. And so maybe you end up fooling yourself by using a more complicated model that you can't fully interpret. And some of these techniques, because they rely on techniques like cross-validation in order to select variables that don't overfit, right? So give very good fit to the training data, but generate poor out-of-sample predictions. Although they rely on that cross-validation in order to fit a slightly more parsimonious model, cross-validating against other survey data isn't the test of MRP. The test of MRP is how well it does in predicting outside of the survey to the actual world. And we only ever test that in election forecasting or some other rare examples. But you could have a cross-validated model that performs really well, but if the sample is junk, you're still going to have poor MRP predictions. Or to put it slightly differently, if you do this fancy variable selection and it never tells you to include the weighting variables that your polling provider suggests, then something's gone wrong. So those are the more complicated methods. Assuming that you're able to use those methods, what kind of outputs would you end up with? Well, you might be using these MRP outputs for description, and just in the same way that you would if you're reporting the results of a survey where you'd use the margin of error, you'd have to indicate some measure of uncertainty if you're reporting MRP results, a different form of confidence or credible interval. And usually these are pretty large because MRP is not a silver bullet. So if I give examples from my own work, conservative vote share in different areas, pick Aldershot because it's one of the first in terms of alphabetical order. You've got 90% credible intervals that are 10 percentage points wide. Right? We're not achieving credible intervals that are like 3 or 4 percentage points wide. If you are dealing with one of these tricky states like Alaska, then if you've got a small sample, just 1,000, if you're trying to spin gold out of flax and take a typical national level sample and generate state level predictions, your credible interval is going to be 20 points wide. Much easier if you're just caring about California. So those credible intervals, they're going to look big, but you got to get beyond that. You got to report them, even if they look big. If you're not primarily interested in description, but you're using these as correlates in a regression model, then you do want to pay attention to the imprecision of your estimates. It's well known that if you have a linear model, then measurement error in your predictors is going to bias your coefficients towards 0. So in my own work, where I look at substantive representation, sometimes I do have simple linear models, right? And I want to estimate a coefficient which tells me how strong the link is between what an area thinks and what an MP does. And it'd be terrible if I reached the wrong conclusions about the quality of democracy in a country because it failed to account for measurement error. And that's just not just a theoretical issue. If I can give a practical example, I am working on a paper at the moment about the effect of local opinion on party members' opinion, and whether they move with local opinion or whether they're fixed at one point. And so when I estimate a model which ignores measurement error, I get a coefficient of roughly 1/3. Each unit change in area opinion, 1/3 of it passes through to party member opinion. Not great. If I allow for measurement error, that coefficient goes up to 3/5. Each 1 unit change in area opinion, 3/5 of it, more than half, passes through to party member opinion. So when you've got the MRP estimates, the hard work doesn't stop there. There is still a little bit more that you can do. So I'm conscious that I've run a little bit over time, but hopefully that's been a helpful introduction to the basic concept and has helped you think through some of the requirements that you would need for MRP and how you might use MRP in some of your applications. So I'm going to pause there for a moment, and hopefully we've got some questions which have come up in the interim.
You will definitely have questions for me, and the audience is encouraged to type in their questions in the Q&A box, and I'm going to be basically passing them on to you. Already some questions are appearing. Chris, amazing! Thank you very much. I think this is exactly what I was looking for. An introduction to MRP modeling with the secret sauce involved and a lot of practical advice as well. I was one of those things that I was interested in is what we were covering in one of the final slides. So you get, for example, public opinion at the constituency level in the UK. Can you really use it as a predictor in a cross-sectional OLS? And because of the measurement error, and that was very helpful. And one of the questions that showed up is, how do we account for measurement error, like you mentioned?
Yep. Okay. Do you want me to take that now?
Yeah. Go for it. Yeah.
Yep. So this is something that I skipped over for lack of time, and also because it does get into specifics. So it's easier for Bayesians to incorporate measurement error into their regressions, and it can be done in one line of code in a package that I use, which is BRMS. So if I wanted to include a covariate which was measured with error, this is how it would look in the syntax used by BRMS. I'm creating this model object, which is the result of calling the BRM function. I've got my dependent variable on the left-hand side there before the tilde. And then I wrap my measurement. So here I've got the principal covariate, my mean, my posterior mean from my MRP, or my point estimate. And I'm telling BRMS that that variable is measured with error, and that the standard deviation of that error is given by this other variable. And in this particular case, because we would have repeated, might have repeated observations from the same district, I might also add in a grouping factor. So if you're just doing a cross-section of MPs, you wouldn't need this stage. You could just omit everything that's highlighted there.
Is this what's going on behind the scenes in the code here? Is it similar to the frequentist version of Cymax, or?
Yeah.
Okay, got it.
That I think would be the
closest
frequentist equivalent. So what it looks like written in terms of formula is, you've got some y you're predicting, and you're going to predict that y as a result of some intercept alpha plus this unobserved or latent variable x star. We don't see that x star, but we know that the observed measure is going to come from a distribution centered on x star with a particular standard deviation.
I mean, do you wanna make a comment here, a more general comment on the importance of going Bayesian for MRP? I mean, Gilman, who started the whole thing, of course, she has a long history with Bayes and everything. Is it like a prerequisite? Is it, how important are priors, setting up the priors and whatever? Like a general comment on Bayes and MRP, if you could.
So the chief advantage of being a Bayesian when it comes to MRP is that it's relatively easy to generate these estimates of uncertainty. If we were just generating a single prediction for each area, there are different frequentist ways of getting a prediction interval for that single observation. But we're not generating a single prediction, we're generating predictions for all the different voter types in that area.
The frame.
And so there's no obvious way of taking, well, I've got the prediction for this type of voter, and I've got the prediction interval, but how do I combine that with this other prediction and this other? So if you're a frequentist, it's quite hard to generate those estimates of uncertainty because you can't just add up all those prediction intervals. If you're a Bayesian, if you end up with a posterior distribution of parameters, all you have to do is just say, well, I'm going to take the first iteration in my posterior distribution. I'm going to take those values. I'm going to make my predictions. I'm going to move on to the next iteration and the next iteration and the next iteration. And I'm just going to average over all of those.
Good. There's a question from the audience who says, thanks, Chris, very interesting and useful. My question is, how big a problem is the freshness issue of the post-stratification frame? For example, will the new census data reduce bias for MRP in the UK? I think if I were to rephrase this slightly, I mean, the last census was 2011. How good it was for 2017 or 2019, or put differently, in a counterfactual world where we had a better PSF or better census data for 2017 and 2019, would we have even better estimates?
The short answer is I don't know. I can tell you that as a matter of practice, the people who are doing MRP now would not be working from the 2011 census, but would be working on the most recent annual population survey.
Right.
That has limitations. So the education information in the annual population survey is only collected for individuals of working age.
Okay.
There are fixes around that, but freshness is important enough that people will not use the census and will instead use census-like government surveys like the ACS or the Labour Force Survey.
I mean, there is a bit of an issue there, not an issue with the technique or anything. I'm just wondering, you have three types of error. Actually, yeah, two types of error. You have sampling and measurement error at the survey data.
Yeah.
Okay. But you also have sampling and mostly measurement error in the non-survey data, because as you said, sometimes it's a survey, sometimes it's a. So which one affects the results more? Not in terms of the validity of the predictions, how the measurement error or the sampling error affects the precision of the estimates from the MRP. Where would you invest money to reduce the error? To put it in a more practical.
In the quality of the sample.
Right.
So in the work that I've done for observation, I've always worried about the quality of the sample. And in the end, it's always come through in that the general election predictions we do have been pretty good. If I use those same post-stratification frames with other incoming samples, the results are not always as good. Perhaps because there's an oversampling of engaged people, for example. That's one of the common problems. You get too many engaged people, they're hyper volatile, and they respond to new information, and maybe minor party X is overestimated in your analysis.
Yeah, exactly. So we have a question here from, I'm not going to say from whom. He says, thanks a lot. Does it make sense to predict variables which are subsequently used in a time series analysis? Or putting it differently, how reliable would temporal variation predicted by MRP usually be?
Okay, I'm going to give a reaction to this question, and then the original questioner can maybe jump back in if I've misinterpreted. Yeah. So if you want small area estimates of opinion over time, you could do it in two ways. You could just do it year at a time. So you've got discrete MRP models for each time point. Or you throw it in one large model, and you can either just say, well, the effect of time is just a random intercept that shifts everyone up or down.
Like a second level? Like a third level?
Yeah.
So is this the new Gelman thing? Is this the new Gelman paper?
I mean, wherever I look, there is always a new Gelman paper.
I think he did one for the. Okay, that's fine. I'll have to check that.
I mean, the super sophisticated way of doing it that I don't know whether Ben Lauderdale has experimented with it, but is to have your coefficients follow a random walk over time. So you've got a coefficient for age 18 to 24 in 2009, and your coefficient for age 18 to 24 in 2010 is equal to the coefficient from 2009 plus a little bit of random noise. So that ties all of your coefficients together and allows you to have temporal variation without too much loss of efficiency.
So, I mean, there is an interesting kind of pattern after 2008, I would say, and 538 and election predictions. And what happened was suddenly you had a lot of pollsters coming in, a lot of polls coming up. In the UK, the same thing. Suddenly you get new pollsters churning out results every day. And one of the things that we did was, okay, let's try and pull them together. Let's try and see across time how public opinion looks like in terms of voting intentions, to see whether we can understand public opinion right now. And of course, it's always this debate. Actually, it's not even a debate. I think it's I don't think there is any competition there. But I mean, what happened to good old uniform swing? I mean, how much better is MRP from a simple uniform swing where we just look at the latest Gallup poll in May 1993, and we extrapolate across the 615 constituencies back then, and we say, look, probably the Tories are going to lose the next one. You know.
Yeah, I mean, I've said in the past that MRP can be a really good way of extracting money from hedge funds, because here you have people who are prepared to pay an awful lot of money for ultra marginal improvements.
Yeah.
I'm not saying that they're wrong to do that. Maybe that matters for their business model, but the improvements are marginal. And certainly it is possible to have an MRP model which does not outperform UNS.
I mean, I could imagine, for example, that the 2016 referendum, because there was no prior kind of knowledge and you had a different electorate, it would be better estimated with an MRP, isn't it? Based on the fact that you have different turnout, different information, no swing, of course, in terms of, you have a slide for me. That's amazing.
Well, that's use case 2, isn't it?
Yeah, exactly.
All right, so before the 2016 referendum,
exactly,
I produced, I think it might have been just MRP with area level covariates, just because I wanted something to help me interpret the mind. And it was incredibly predictive, just because the referendum tapped into deep demographic.
Yeah, exactly. Exactly. And I mean, I know this is probably, I don't know if you're even allowed to talk about this. There's a lot of discussion about red wall voters, Labour, and the Tories. Do we get anything from? I mean, the swingometer doesn't help us there, but MRP can kind of tell us what public opinion looks like after the 2019 election and the end of Brexit and the whole pandemic thing going on. Have we learned anything in that respect? If you're allowed to say something, of course.
I haven't done any vote intention modeling since 2019, so I can't comment directly. I mean, I'd be fairly skeptical that you could ever make a confident claim about a small number of constituencies.
Right.
The areas where people have picked up things in the past by modeling in this way have typically been kind of region specific.
Right.
But you could get that looking at crosstabs.
As always, that's the rule of life. Crosstabs give you everything. I have a question here, and I think it's a good one, if I got it correctly, of course. So, could there be a longitudinal application with MRP? Okay, if we are interested in how public opinion has changed due to a long-term government program, which may have been implemented in certain areas, like in a treated area, is there a possibility to leverage benefits from putting these data together? So I guess it's like a diff and diff kind of setup where you estimate MRPs. I don't know if there are different MRPs before and after the introduction of the treatment. I guess that's what the question is coming to. Please, the person who asked the question, let me know if that's what you intended to ask. Are there possibilities to do something like that?
Well, that sounds like the MRP would be providing the outcome variable in that case.
Right, and we don't like that.
Well, my question would always be, and I don't want to get into debates about methodological individualism, but why can't you model the individual level opinions? Because those individuals, in virtue of being in a particular area, were treated.
Right.
So you would have to be. It's really hard to think of anything MRP could produce at the area level which couldn't be decomposed into a sum of individual opinions.
Okay, good. I think the question now kind of opened up to me, kind of encouraged me to ask the following. Yeah, and actually that was the question, so well done. Probably because of what I do for a living, I conduct experiments. I would always be interested to know whether experimentation, so survey experimentation and MRP would ever be producing something meaningful for anyone. I haven't seen work doing that, and I'm just wondering whether there is enough power, and I mean experimental statistical power, to extract any average treatment effect using MRP.
I'm not sure, but if there is someone who is working on it,
that would be these folks there.
Really, one of this group of authors.
I know people have tried. I never got back to ask whether they found anything, but that's fine. There's this new wave now that comes in from Lucas Lehmann as well. So with Mrs. P and now the auto MRP, that I think, and also the paper by I remember the author's name now, where they look at sparsity of data and they're trying to. It sounds to me, without being an expert, like a feature selection kind of thing. You were slightly ambivalent, I would say, in some aspects of this, but you were happy with what the Mrs. P did, the Lehman and the et al. Paper from 2018, if I'm not mistaken. What are your thoughts on this? How can machine learning, and apart from BART and trees and whatever, which is just for the specification aspect, how much can we improve, you think, with machine learning?
I mean, my general view is that most of the improvements in predictive accuracy come from substantive knowledge of the opinion being studied rather than advances in estimation.
Rather than gimmicks, yeah.
So there's a recent proceedings in the National Academy of Science paper on a kind of collaborative multi-team evaluation of some social services program in the United States, where they had really rich information, thousands of covariates. And they gave it to 40 different teams, encouraged them to use machine learning techniques. And ultimately, the predictions on their key outcome of interest were not very much better than the logistic regression with 4 carefully chosen variables. So if I had to recommend an area for improvement, I think you can use machine learning if you're using MRP repeatedly. If you're using MRP for a one-off, I think it might be a big investment for not much return. But if you're a polling company and you produce an MRP analysis every quarter, then certainly it would be worthwhile to investigate this. If you're a researcher looking for a covariate, no.
Good.
I'm skeptical.
Skepticism is always productive and fruitful, I think. So let's try and look at some code. I think the audience, they're somewhat familiar with R, and because I've seen this code, I think everything is fairly straightforward, and I'm sure they're going to be able to follow everything. So let's get going with that. And if there are questions, I'm going to be posing you. So I still encourage the audience to type in questions. I'm going to be monitoring the table here, and I'm going to be asking the questions myself. So I might be interrupting you at some point. Okay.
Yeah, no, that's good, because interruptions are very good when it comes to code.
Okay.
Okay, so I'll show you the GitHub repository. I just put up hours ago. We've got two folders here for two different tasks you might carry out. I've got one folder which is going to show you how to rate a joint distribution into the form that you want, and one which just looks at the model itself. I'm going to focus on the model because you're always going to be modeling, and you might sometimes be raking. So I'll start with that one first and go back to the browser for the moment. So in this directory, I've got two R source files. I've got a helper file, MRP.R. This is the code that was attached to this Political Studies Review article. And I've got my code file model.R, which actually does the work. So those are the two code inputs. And then I've got three data inputs. I've got some area level predictors. I've got the BES from my individual level stuff. And I've got a post-stratification frame. So that post-stratification frame is there for you to use. This is what it looks like. We've got, and maybe this would have been useful in the front half of the presentation. So it's just a data frame with a row for each type. So here we've got Aldershot again. This voter type is made up of people who voted Conservative in 2015, Leave in 2016, who are male with no education, who are aged 25 to 29. And we've got a weight there, which is very small. We've got a count, so after doing all the raking, we suspect that there are 7 such voters in Aldershot. There is one omitted category here, which would be the 18 to 24 category. I've filtered out all the categories where the count is 0 or 0 after rounding. So that's what our post-stratification frame looks like. And if you go through the code in model.R, then most of the code is actually reading in the data and making sure that it looks like the post-stratification frame, the data that we're going to be post-stratifying to. So most of the code is fairly boring. So if I can scroll through here, there's a lot of selecting of variables. This is, by the way, this is all written in the tidyverse style. Some of you who are used to base R might be looking at it and thinking, what the hell is this percentage sign, right arrow, percentage sign operator, this pipe operator? It's a different way, different style of writing our code, which may be more readable. But we have a whole host of recoding operations which we carry out. So there's a lot of boring stuff which goes on. But I'll show you how to do the actual modeling, or how it looks 2 different ways. I'll show you how it works with BRMS, and then I'll show you how it works with my wrapper function, which hides some of the tricky stuff from you. So what we have at this stage in the code, we have an individual level data called ind. We've got a post-stratification frame called PS, and we've got our auxiliary data, our area level variables in aux. So one of the things we do here is we scale all of our auxiliary or area level predictors. Spiros, you asked about the advantages of being a Bayesian. One of the disadvantages is all your models take a long time to run, but you can speed them up and help prior specification if you standardize all of your variables to have a mean of 0 and standard deviation of 1. So all those percentage variables, unemployment rates, they've just been standardized. And once we do that, we merge those area level predictors in, and we set up our model. So in this particular application, I've created my dependent variable, which is whether or not the respondent prefers PR to first past the post. This is a good teaching example because there are only 1,000 observations. So the model only takes 4 or 5 minutes to run instead of 16 hours. Right? And in order to model that, I have random intercepts for all of the different categorical variables in my post-stratification frame. So we've got random intercepts for how people voted in 2015 and 2016. I've even got a random intercept for gender, despite the fact that there are only 2 levels there, and I could easily encode it as a fixed effect. So all of those up there, they're in my post-stratification frame. And then I've got a series of other predictors which are in the area level predictors. I've got who won the constituency, which I've turned into a random intercept. If you don't turn it into a random intercept, it becomes very, very hard for the model to estimate the effect of being in a constituency represented by a Green MP or a Plaid Cymru MP. And then all these lovely, lovely area level predictors, like what happened last time. Because this is a Bayesian model, and because we want to check that our Bayesian sampler is exploring the posterior distribution nicely, we set off 4 different chains which are going to explore that posterior. And on my desktop machine, I'm able to set each chain so that it works on a separate core of my computer. If you had a laptop with just 4 cores, then you maybe want to run 3 chains and 3 cores, because if you set BRM to use all your cores, your laptop will be unusable. So there's some details of the estimation there. I slap a prior on some of the area level predictors, and BRMS allows me to specify those in a fairly intuitive way. So I stick a standard normal prior distribution on everything which has class B. So every covariate, not the random intercepts there. They have an improper, they have a different prior. That might sound restrictive. Ultimately, it's not that restrictive. So if we have a standard normal prior, and we've got this dichotomous outcome, and we're modeling it as a multi-level logistic regression, we're saying, oh, this coefficient could be, as big as 2 standard deviations up, could be as big as 2, could be as small as -2, 2 standard deviations down. But if we're moving, from -2 to +2 on a logistic regression scale, that's kind of close to saying like predicted probability of like 5% to 95%. So we're saying that this single covariate alone could turn our prediction from close to 0 to close to 1. So if it sounds restrictive, actually it's not. It's allowing for really powerful predictors. There are a couple of other details about the estimation. These are just kind of magic numbers. I've put in the magic numbers that have worked for me in the past and make sure that my models are reasonably speedy, but still manage to explore the posterior and don't throw up any cryptic error messages. And because this particular variable only has 1,000 responses, this model is fairly quick to estimate. If you have the full BES and you're just doing a multi-level logistic regression, this could take 8 to 12 hours, depending obviously on the speed of your computer. So check all your codes, leave it to run overnight. When your model finishes, then you have the job of post-stratifying your predictions. So I've given the code here for how I might do it in this particular case. I would go through all the columns of my posterior distribution. So I've got a posterior distribution with one column for all the different, oh, sorry, scratch that. Let me take you back to the code because I've missed a step. Might be easier here in GitHub because there's code highlighting too. So I've created the model. What I do is I get the linear prediction out. So just multiplying the coefficient values by the covariates in our post-stratification frame. So this is done in BRMS by the posterior underscore linpred function. Takes as arguments the model we've just estimated, the new data that we want to predict for. I'm doing this quickly, so I just said, just give me 2 samples from the posterior. You can obviously increase that depending on how much accuracy you want. The more accuracy you require, the longer this stage will take. It's time consuming, even if you have a small number of observations you're modeling, because your post-stratification frame is still going to be 1 or 2 million rows long. So it's slow and it's memory intensive. Once I've got my predictions out, I transpose them so that I've got all the predictions going along the columns. And so now I just go along all of the columns, set a little reminder to myself. I can see a little dot as we go. And I use the predicted probabilities after transforming them appropriately to predict for each row the expected number of people who prefer PR given the number of people in that count. So that's, the 7 people in Aldershot who had such and such characteristics. I then aggregate that by constituency. I do the same for the count, and I end up just dividing. And I place that into my list. And so what I'll end up with is a list which contains 1 data frame for each iteration. So I bring those together, I group by the constituency, and I summarize and get the posterior mean and some quantiles. So here we have quantiles for a 90% credible interval. That is how you would do it with BRMS. And that means that any model that you can write in BRMS syntax, you can MRP with. So because I show you that in that way, that means that now you've got the basic template for lots of different applications. If you know you're always going to be dealing with a continuous outcome or a logistic outcome, then you could use this much shorter syntax, which takes care of checking all the variables match, standardizing the variables, setting the priors. All that is done from this code, which is an MRP.R. Here, the notation is slightly different. We've got a 2-part formula where all the variables that should be in the post-stratification frame are before the bar, and all the area level variables are after the bar.
So just to make it clear to the audience, what you do here is you first run the MRPR code. It's stored in your machine, and then you call it with the source command, and you can estimate it. Essentially, you create a new command in a different tab, and you run it in a second one.
Exactly. So my problem here is that I'm lazy and I haven't gone on to develop this into a package, right? That would be the user-friendly way of doing it. I've just stored it as a source file and read it in using that code. So that would be the alternative way of using that source code to achieve the same result, very slightly quicker, but not substantially so. So that's the code that you can adapt to your own purposes. There are some advantages of using that wrapper. I think you might want to experiment with the wrapper before doing it yourself, just because it's a pattern which has been shown to work on other data sets. What that wrapper won't do is it won't work for multinomial outcomes or more complex outcomes like that. So if you do want to get into the election forecasting game, you won't be able to use that wrapper to do it. Okay, so that's a template for the actual MRP itself.
Before moving to the rake,
yeah,
can you comment on the differences between BRM and RSTAN with respect to the estimation?
There aren't really any differences.
Okay.
BRMS is just built on top of RSTAN.
Okay, good. Okay.
Okay, so that's code you can use if you have a post-stratification frame. We've also got codes which shows you how you might go about constructing a post-stratification frame. My example that I put up there is a post-stratification frame for the upcoming Scottish Parliament elections, because I'm part of the Scottish election study team. If you go into the project folder, you'll see that I've broken it down into 4 distinct stages, right? So the first step you have to do is you have to get your marginal distributions. You have to know for each constituency and each variable, what proportion of the population falls into each category. That's clearly key information. If you want to impute vote intention, you're going to have a model to do that. And you want to have some source of data that you can use as a joint distribution that is going to be raked. So in this particular case, I've not actually included the joint distribution. That's because it's the annual population survey microdata, and they tend to get a little bit sniffy when people redistribute that. But it is available on the UK Data Service, so you can sign up and download it for free. One of the things that you learn when you're constructing these post-stratification frames is you get incredibly familiar with different statistics agencies' websites. So if you look at the code for getting the marginal distributions, there are a whole host of really long, complicated URLs. I can tell you that URL gives you a table showing educational qualifications for Scottish Parliament constituencies from December 2019. How did I get that URL? Well, I went to NomusWeb, which is an excellent website which exists to turn national statistics products into things people can use. So for my case, I was interested in the labour force survey. So I can click through all of these things, and the website will even give you some tips if you want. And it turns out to be fairly easy, even on not one of the most common geographies, Scottish Parliament constituencies, for me to get information on different types of variables. So scroll down to qualifications. And actually here, they'll try and give me a two-way table. They'll try and give me education by age. I don't want that. I'll just take the top of these categories, NVQ4, which is tertiary, NVQ3, upper secondary trade apprenticeships, NVQ2, and so on. And when I click through all of these things and get the most recent data, oh, they've updated it. They've updated it since I last checked this. So the educational qualification information is only available in the December release. Again, something I know which is taking up space here, which is not necessarily a good thing. So once you go through all of those things, Nomus Web has a way of allowing you to download that programmatically, just given a URL. That's really handy because it means you're not saving all these CSV files on your hard drive with funny file names. It also means that someone else can replicate your work more easily. If you're doing this for the UK or for some other country, you too will get incredibly familiar with websites like these. So, if you've got the marginal distributions, and you followed some kind of procedure like that, then if you follow the code, you're going to end up with this nice format that I use for my targets. One row for each constituency, variable, category, combination, and the count. So these are just the marginal distributions. So we know that in this particular area, 5% of people are in the 16 to 19 category, not combined with anything else. If you've got one of those, a list of targets, if you've got a joint distribution, which in my case comes from this annual population survey that I can't share with you, then you can start raking. And I've given you some code to do that. And I have to be honest and say that this is all built on top of the ANES rake package. So I've not done anything complicated. I've just made it so that you can repeatedly rake to different constituency targets. When you're raking, though, some practical problems that you might find. So raking works by multiplying different cells, the weights on different cells, so that when you add up those weights, they match the targets. But sometimes your joint distribution might have a 0, or your target distribution might have a 0. And in this case, no amount of multiplying or dividing is going to get you to 0. Unless you multiply or divide by 0. So in some cases, the raking can get stuck. If, for example, you have, let's say it's 16 to 19-year-olds with a PhD. And my expectation for the number of 16 to 19-year-olds with a PhD in any Scottish Parliament constituency would be 0. And so that might be a problem. You can fix that either by ignoring the error or making your post-stratification categories a little bit coarser. Generally, this raking procedure works better when your joint distribution is much closer to your targets. Here I'm using a joint distribution from the annual population survey, plus some vote intention I've added on, and I'm raking it to other targets from the annual population survey. So there shouldn't be that much of a problem. In practice, ANES rake does complain a bit, but when you go in and look at some of the weights, the errors or the non-convergence problems are reasonable. It's cell counts which are off by 3 or 4 people. Not a big issue. So I leave that code for you there to use. I'm conscious of not going over it in detail because, well, if you're still one of the 33 participants here at 7 o'clock on a Thursday evening, you also probably have the incentive and the willingness to look at the code later and work out what's going on. But if you've got any problems with any of that code, if you're trying to create a frame for your particular country, do drop me an email. My email isn't on the slides, but I'm sure that all of you being intelligent people can find out a way to contact me. So I'm going to bring it to a close there and answer any kind of remaining questions.
Excellent. Thanks so much. I mean, I wanted to make this comment not only based on what you presented today, but also what Chris Barry and Aaron Frey presented on Tuesday. This should be the standard for transparency. I mean, this is how social research should take place. I mean, when I started my PhD, and I think it was around the same time as you did, we couldn't find anything. We didn't know what was going on. We would just see tables in the APSR and the AJPS, and we didn't know where they would come from. And we have made so many steps into into transparency and sharing and proper way of conducting research. And the students who are watching this should really consider this as the way to do research now. So many thanks, Chris. This was illuminating in many different ways. And I'm sure that students benefited enormously from your presentation. I think it's one of those things, MRP, that is going to be around for a bit of time, not only because people invest in it, as you said, but also because there is room for improvement, there is room for experimentation, not in the social experiments kind of way, but to see how things are going to look like in the future. So it was just great that we had you at the spring school in DPIR. So let me just, if you could give me a couple of minutes, because we are entering, this week is about to end for us. So this was a week, not in the way that we anticipated it. So we had no idea that everything would be online. We kind of knew we were prepared for this, but we had plans for a face-to-face spring school if something good would happen. It didn't happen, and we had to do it like this. And it's for us, the fact that we were able to have 2 sessions like that is just an amazing thing. And I want to thank you. I want to thank the presenters on Tuesday, but I also want to thank the students who took place, who came to us and trusted us with their education for 5 days. It's 4 days now, and 1 more day tomorrow. I want to thank you so much. I'm sure you've learned a lot. I'm sure it was challenging. It's really hard to learn online. I spent a year teaching online and teaching methods online, and it's the hardest thing I've ever done in many different ways. So I think it's just great that you were that you joined us, and I really hope that we're going to see you next year at the spring school, but this time face to face, so that we can really enjoy our time at Oxford. Unfortunately, this year we had to constrain ourselves to just academic events and not social events. And hopefully Chris will come next year as well and tell us how hard it has been or how easy it has been to work on things like that in political methodology, being a methodologist, essentially, what it means to be a methodologist. Okay, there's a final question from the audience, which is, I think it's an important one now that I think about it, and we should have probably mentioned it. You had a slide with a literature, like a background reading list. So the question is, thank you so much. Could you recommend any books or any other resources on MRP?
There are actually a fair number of tutorials. So if you don't mind working with US data, it's pretty easy to Google your way to like MRP tutorial. You type in MRP tutorial and then ACS. Lots of people have worked examples, right? The ACS is so common and so easy to use that lots of people have it for that.
If my memory doesn't fail me, there's the Jeffrey and Lachs code for their same-sex marriage paper in the US. So they have their code available, but it's an old page. It's one of the first papers that came out, isn't it?
Yeah.
It might be a bit different. The book, I mean, if there was one book, if there were 2 books to recommend, that would be the Gelman and Hill multi-level modeling book by Cambridge University Press, and the Gelman book on why some states are poor. Red state, blue state. That's the thing.
I think that's the right approach, because ultimately I don't feel like I know much about MRP. I know a little bit about multi-level modeling, and I know enough data carpentry to get predictions out of my multi-level models. So I think if you learn a lot about Bayesian multi-level modeling, MRP will come naturally to you. And the two books you just recommended are excellent for that.
I mean, the Gelman and Hill book, it's like it has a clear MRP. I don't think they call it MRP necessarily, but they use the PSF. They collect predictions. They have code. It's all filled with our code, not tidyverse. It's an older book. But I mean, when people ask me about MRP, I say the first book you're going to read, especially if you're not savvy in stats and R, just read the Gelman book, Red State, Blue State, to understand what is the logic behind it. So I think the motivation there is amazing on what do we learn from different voters nested in different areas and how it affects their voting preferences. So that would be my recommendation. Okay, it's 7 o'clock. Again, Chris, thanks very much. I want to thank the audience for staying for 2 hours with us, almost 2 hours. And hopefully we're going to meet in person and chat about all those things that we talked about today. Okay, so guys, thank you very much for staying with us. Enjoy the rest of the week and the nice weather. Bye-bye.
Bye-bye.